Hello everyone, and we are back together. I'm back with another very interesting question on acids and bases. Let's just quickly have a look at it together. So, they say during a reaction, 25 cubic centimeters of hydrochloric acid solution of a strong base, okay, of barium hydroxide with a pH of 13.6, okay, was added to 40 cubic centimeters of aqueous solution of sulfuric acid with a concentration of 0.15. Now, they said to us we need to. Okay, so the first thing about this question is that they want us to calculate the concentration of barium hydroxide, right? Now, please remember that if you wanted to get, now I want you to be really careful here. Right, so we're going to take the pH. In fact, there's a much easier way of doing this, okay, so that you get to the barium hydroxide. So remember that when you want pH is minus the log of the hydronium ion concentration, right? That's what pH is, okay, right. So now when you want the concentration, now remember I am given the pH and I want the concentration. Please don't waste time, so it will be 10 to the minus pH, okay, right. So this will be 10 to the minus 13.6, okay. You can calculate the actual concentration, so that will be 10 yx negative 13.6, okay. Yeah, that gives me a very weird value. All right, so I'll come back to that, okay. In fact, I'll leave it exactly in that form. Now remember, this is the concentration of the hydronium ions, but what are we looking for? The concentration of barium hydroxide. It does not have hydronium ions. So what you do is you'll use the ionization constant, okay. Obviously we are assuming this is at 25 degrees, okay, times OH minus, that will give us 10 to the minus 14, okay. You are given this formula, by the way. So this is 10 to the negative 13.6, and I'm looking for the concentration of hydronium ions, okay. That's 13, sorry, that's 10 to the minus 14, sorry. So I'm just thinking about dividing, actually. 10 to the minus 14. So of course we're going to divide by 10 to the minus 13.6. That cancels that. And that's 10 to the minus 13.6. Okay. And you'll see how obviously the concentration of hydronium ions, negative 14. When I take this, if you know the law of exponents, obviously changes sign. So I'll have a negative 14 plus 13.6, and that would give me 10 to the minus 0.4, I believe, right? So we can actually calculate for that instead. Okay, so that's 10, that's yx negative 0.4. I get 0.39. I don't know if you want to, yeah, let's just say 0.4, right? 0.4 moles per cubic decimeters. Now, please remember, we're not looking for the concentration of hydronium ions. We're looking for the concentration of barium hydroxide. Now, what you want to notice is that for every one, how does barium hydroxide dissociate? Okay, for every one, it must, I've written this in the wrong place, so the 2 is outside here, right? For every one barium hydroxide, in this case, what it does is it will give you 2 of those hydronium ions, okay. So for every one there's 2, So in this case, I've got hydroxide ions, and in that case, so I'll say 1 for every 1 barium hydroxide. Okay, I've got 2 hydroxide ions. So the question is, for how much will I have 0.4? All right, I'm sure you can already see it. So it means the concentration, so I'll say 2 times x, that will be 2x, and 1 times 0.4, that's 0.4. So it means that x will be 0.2, of course, if you divide both sides by 2. Right? So therefore, what did x represent? The concentration of barium hydroxide. So in this case, the concentration of barium hydroxide would therefore be 0.2 moles per cubic decimeters. I hope that made sense, ladies and gents. All right, I will actually obviously look at the next question, all right, in the very next video.